I would like to thank our partners that extended their support to this event. Associate partners MENA Clean Energy Business Council, centur EV Charger, who is also the panel sponsor on day one. Supporting associations: the European Association for Electromobility, Electric Drive Transportation Association, Electric Vehicle Association of Thailand. And the supporting partners: Qatar Solar Energy, Fin Value, Electroheads, the Brattle Group, Rare Group, A Great E Incorporated, and our media partner, Circuit Digest.
Thank you very much for the opportunity to come and talk with you today. Just to check briefly in terms of sharing presentation and slides. Excellent. Well, thanks again for the introduction, and good afternoon to everyone who's dialing in for the next 30 minutes or so about the role of electric vehicles in the energy transition. This is a presentation that covers the key findings of our Energy Transition Outlook, which is a publication that we produce annually. So results of our 2021 Energy Transition Outlook, as well as, of course, the insights that we have into our projections for the EV sector and some of the results of the modeling that we've done for that side of things. However, before I go into some of the details of that, for those who perhaps don't know DNV, just as a brief introduction to us as a company, we are a global assurance and risk management company working in the sectors that you can see here. So maritime, offshore, classification and advisory, energy advisory work, and certification and verification and monitoring, software solutions, and certification of management systems and supply chain and product assurance. I work within the energy part of the company, where I lead our electric vehicle sector and help our customers navigate that transition to electric vehicles. So that's just a little bit about DNV, so you know why we're here presenting today. So as I mentioned, one of the reports that we produce on an annual basis is our Energy Transition Outlook. It's our forecast of the energy systems of the whole world out from now until 2050. And here are some of the highlights from that report, and then I'll go into some of the details of the electric vehicle aspects. So we see that in our latest projection, unfortunately, the recovery from COVID-19 spending is something that we consider is a lost opportunity. So in total, there were a situation where there was as the process of the pandemic, there was an unprecedented % reduction in CO2 emissions due to COVID-19 going into 2020 from 2019. However, by 2030, global energy-related emissions are likely to be down by just 9% compared to 2019 levels, which is in sharp contrast to the needed halving of emissions by that time. We see a transition where the global energy system is electrifying rapidly in all sectors, and global electricity production more than doubles over the next 30 years. By 2050, approximately a third of that electrical generation will be from wind, and a little more than a third from solar PV, including systems that are combined with solar PV and storage. For fossil fuels, they are moving from a position where they have contributed around 80% of the share of the global energy mix, and will decrease gradually over the forecast period to the point where they will provide around 50% of the share of the mix. Decarbonized fossil energy is an important aspect of reaching Paris Agreement goals, but uptake, unfortunately, of carbon capture and storage is happening too slow, with just 3.6% of fossil CO2 emissions being abated by 2050, mainly due to the costs of that technology developing. In the hard-to-abate sectors, which currently are responsible for around 35% of global CO2 emissions, we see that the progress in reducing those emissions is stubbornly slow. Hydrogen and its derivatives are seen as some of the main decarbonisation alternatives. Its future production will be dominated by electrolysis, using, in many cases, dedicated off-grid renewables for that hydrogen production. So those are a few of the highlights from the main report itself. It's a report, as I say, that forecasts the energy systems for the whole world, and that is broken down into 10 different regions, taking into account the energy trade between those regions, taking into account the division of those regions based on shared geographical location, the economic development of particular countries within a region, and the energy characteristics in order to generate some of the results that I'll be sharing with you today. So as mentioned in one of the the highlights, we do see that the recovery spending from COVID-19 is unfortunately a lost opportunity. Globally, on average, we are seeing a situation where we're in fact building back as before, rather than building back better. Apart from a few cases, such as within the EU, the COVID-19 stimulus is largely given to conventional energy industry and locking in carbon that really, as a world, as has certainly been highlighted at COP26 recently, we need to continue to move away from. The bold and urgent actions after COVID-19 certainly demonstrate what is possible, what governments can do if they really decide to act sufficiently strongly to address the challenges that we face. So we are certainly advocates of continuing to strengthen the policies and regulations around shifting us towards a net zero future, and really wherever we can, keeping that possibility of achieving a 1.5 degree future, keeping that alive and possible. So unfortunately, not as much development as we would have perhaps liked to have seen. But we do forecast a future where there is definitely a relatively rapid energy transition. Our forecasts here, all of the results that we're showing, are our forecasts of the most likely future. So they're not being forced, one way or the other in order to try and achieve a particular target. We run our modeling in order to predict the most likely future that we anticipate will happen with the energy systems, based on the feedback loops within an economics model of the different systems that are part of the energy world that we live in today, and that will be developed over the future. So a defining feature of the transition is that we expect that energy demand, the total energy demand, to continue rising for a few more years, but peak around 2035, and then from that point on start to level off. So you can see here the demand for energy from transport and buildings and manufacturing, as well as some other sectors. And in all of those cases, we move towards an energy system where the gains in energy efficiency are progressing faster than the continued growth in GDP or in the population of the world. So we get to the point where we can carry on having a continued growth in GDP, but achieve that with less and less energy, or a leveling off of that energy demand. So total energy demand leveling off. In terms of the demand for electricity, although the total energy demand may be leveling off, it's very significant, and this obviously relates to the demand being caused by electric vehicles. We see the demand for electricity going from around 19% of the energy mix to around 38% of the energy mix in 2050, so doubling in that demand for electricity. We see the other sectors, such as oil, dropping away over that forecast period, and similarly for coal. Gas we see as a relatively stable source of energy, but its percentage in total will start to drop a little bit as we go into mid-century. So in terms of where that demand for electricity is coming from, you can see in this slide that for all sectors that we're looking at, from a manufacturing perspective, from a buildings perspective, the demand for electricity is increasing. But importantly, there are two new areas where demand for electricity is going from next to nothing, or not really existing today, to starting to grow to be more significant. And those are, of course, the road sector, or the transport sector in terms of electric vehicles, as well as the production of hydrogen. So you can see those new additions in transport in the grey there, and then a few different sources of hydrogen generation, whether that's off-grid in the colours up at the top of the chart, or grid-based hydrogen production. So in total, that leads to this substantial growth in demand for electricity, and we will see that transport will grow to be approximately 12% of the electricity demand by the time we hit 2050, from levels today that are effectively negligible. Now, where will that electricity be generated from? The electrification of the energy systems that we see happening will be dominated by variable renewables. So by the time we hit 2050, 70% of that electricity will come from solar and wind. Forgive me, the slide says 70% of renewables. That should say 70% of the electricity generation will come from solar and wind. So we will move to an electricity system with much more variability for that generation, and integrating that variability from the generation, as well as the variability in demand that there will be on an electricity system, will be one of the big drivers in the way that electricity system shifts and changes. And of course, the demand, this new demand from electric vehicles, will be an important aspect of that. So on this next slide here, of the overall demand for the energy going into the road sector, by the time we get to 2050, then 30% of that road transport final energy demand will be met by electricity, and more than half of the, albeit much smaller, rail demand will also be met by electricity, but much smaller amounts of electrification in the maritime and aviation sectors. this EV revolution will have a really significant impact on increasing that electrical demand, but also on the demand profile. So we see that the shift in the timing of that demand will change with the electrification of transportation, and that charging itself is going to continue largely to be done at home, but there will be an increasing percentage of en route charging or at work charging, or destinations such as shops and cinemas. Sorry, forgive me. That's got us back to the slide that we were on. So in terms of the scenarios that we're talking about here of where those vehicles would be charged, in all of those scenarios, then significant investment in deploying charging infrastructure will be essential to the success of the EV revolution. And EVs will indeed be a great asset in both integrating their own demand as well as being used to integrate that increasing volume of variable renewables. So going into some of more of the details in terms of our electric vehicle projections, we see that despite growth in car sharing and the development in autonomous vehicles that is occurring today and will continue into the future, the world's fleet of vehicles will certainly expand. So it'll expand by approximately 60% by 2050. However, as we showed earlier, the demand, energy demand from all of those vehicles will decrease because of the efficiency of electric vehicles, where they're 3 to 4 times more efficient than an internal combustion engine equivalent. We see that the number of vehicles will grow in the passenger sector very notably, but also in the commercial sector, and a substantial growth in 2- and 3-wheeler vehicles as well. In all of these 3 subsectors, we see that there's relatively rapid electrification, most rapid, the fastest definitely with 2- and 3-wheelers, then passenger segment, and then the commercial vehicles following next. And to highlight some of that in a little bit more detail, then we see for the passenger sector that important milestone of hitting 50% of the sales of new vehicles being EVs. That milestone will be hit in our forecast around 2032, and as you can see there, it will be noticeably faster for 2- and 3-wheelers and a little bit slower for the commercial vehicle sector. We see that in the commercial vehicle sector, that will be around 2042, with relatively significant variations in the different regions around the world. So Greater China will see a 50% sale share for commercial vehicles, and I should say battery electric vehicles, in about 5 years. Other regions such as the Middle East and North Africa will not see that 50% mark within our forecast period. It's worth commenting briefly on the fuel mix, and I know that Philip commented on this as well. For the passenger sector, we see that the vehicle technology will be dominated by battery electric vehicles, and that really we don't see any realistic scenario where fuel cell electric vehicles will play a role for the passenger vehicles. However, for the heavy duty vehicles, for the longer haul vehicles where The range is significantly long, that the weight of battery that you would need to take in order to achieve that particular range would be both, financially potentially detrimental for the business model for those logistics and freight companies to be able to make it work, as well as the level of utilization of those vehicles, and therefore the importance of charging them swiftly. That for some of those journeys, then certainly we see fuel cell electric vehicles playing a role, and we estimate that would be somewhere around 15% of commercial vehicles will be fuel cell electric vehicles by the time we hit 2050. But for the smaller vehicles, 2 and 3 wheelers and passenger vehicles, we see that as all battery electric vehicles. Looking at the range of adoption, as I talked about for commercial vehicles, then we certainly see quite a variety in the pace of adoption of electric vehicles. It's the same here that you can see for passenger vehicles, which is influenced, both in our modeling, but definitely in the real world as well, of course, is influenced by a number of factors that will impact that rate of change and rate of adoption. So being dependent on the development of the economies in those particular regions, the particular supporting policies that they'll be in place, and also importantly, the level of infrastructure in place. So those regions that perhaps have weaker grids, and it might be tougher to implement the charging infrastructure that will be required for electrification of vehicles, then that will have a dampening effect on the rate of change for the electrification of transport and in this case passenger vehicles. So we predict that Europe will be one of the leading regions for electrification, with China following shortly afterwards, and then other regions such as North America and OECD Pacific, so the more developed economies in the Pacific will be changing next. Thinking about the comment that was made earlier around the role of electric vehicles in the grid itself, so they play a fundamental role in the energy transition because of some of the points that I mentioned earlier. The fact that they are so much more energy efficient than internal combustion engine equivalents, that it results in that reducing demand in energy. The emissions over the lifetime from a electric vehicle, CO2 emissions, are less than half of an internal combustion engine equivalent with the grid as it is today, with the mix of electrical generation that there is on the grid today. As that grid gets more and more renewables on the system, those vehicles will get cleaner and cleaner, their manufacturing process as well, but of course the operation of those vehicles will get cleaner. So it reduces energy demand, it significantly reduces CO2 emissions, but importantly, as we're highlighting here, their role within the energy transition goes beyond those energy and CO2 aspects, and they are able to become a really valuable and vital storage technology available to the grid. So we can see that over this forecast period, the traditional storage technology available to grid operators of pumped hydro storage, which dominates at the moment, will start to be supplemented by lithium-ion battery storage, so grid-connected storage, over the next sort of 5 years. That starts to grow, but then from 2025 onwards, we start to see EV storage starting to play a role, growing to the point where together with long duration and grid connected battery storage, the total storage available to grid operators by the time we get to 2050 will be vastly greater than the storage available from pumped hydro. So really playing a very important role in the flexible grid of the future, enabling not only integration of its own charging needs, but also, as mentioned before, supporting that integration of the increasing volumes of variable renewables from wind and solar PV. So those are some of the highlights from the main energy transition outlook results and the electric vehicle aspects of those results. The last couple of slides, I really wanted to come back to the challenge that we're facing as a world to try and reduce emissions wherever we possibly can of CO2 and steer us towards a future with lower rises in global temperature. So we can see here, as part of the energy transition, of part of this most likely future, CO2 emissions definitely do reduce, and that's great. We can see there's the reduction in from 2019 to 2020, which was hugely influenced by the global pandemic. But then emissions have come back up through into this year, and then we anticipate that although they won't hit the peak in 2019, again, we think the most likely scenario is that they will continue to drop. The level of that reduction is too slow. It's just not fast enough to give us the chance of really keeping global temperatures to a reasonable level in terms of the rise. And the next slide here indicates what level of carbon budget we have available to us. So the cumulative emissions as we go through time will exhaust the budget for a 1.5 degree future by the time we hit 2029, and then we'll go past the 2 degree budget in 2053, with our projections showing that, unfortunately, the most likely future that we have with the energy transition outlook that we're showing will be one where there's a rise of 2.3 degrees above pre-industrial temperatures by the time we get to the end of the century. So this is clearly a scenario that wherever possible, we need to continue to work to try and change and accelerate the pace of the transition to move away from a future that will be very costly for much of the world. To highlight some of the potential pathways to achieve that, to end up with an accelerated energy transition, and one where we do meet the Paris Agreement target of limiting global warming to less than 1.5 degrees above pre-industrial levels. We also have relatively recently released a report looking at the pathway to a net zero emission world. So this is also available from our website, and includes roadmaps for different industry sectors, has the same 10 global regions, and looks at the technologies needed to contribute to that rapid change. So both the main Energy Transition Outlook publication that I've highlighted the results from today, this pathway to net zero, and all of the electric vehicle projections and results are available, publicly available in our reports. And in the interests of transparency, then the data behind the charts that I've shared today are also available. So you can go to our website there and download the data that you may need to look at any of those details.